All right, I have three tables here. We want to know which table or tables are proportional and why. So for a table to be proportional, we have to have a constant ratio, okay? And it needs to, if we continued on the table, it would include the origin, 0, 0. It may not have 0, 0 in the table now, but we have to determine if 0, 0 would be part of the table if we continued on the pattern. Okay, so let's take a look at this first one here. Well, let's see. Are we going up by a constant amount? Here we're going up by 1, 1, 1, 1, 1. Okay, we're going up by 1 each time. 7.5, right? Let's just keep drawing this. 7.5 to 10. Well, that's up by 2.5. Oh, that's up by 2.5. That's up by 2.5. Let's look at this. From 6 to 8, we go up 2. 15 to 20, we go up by 5. Interesting. Okay. Well, if we look at this, right? Well, 2.5 divided by 1, that's 2.5. Same. 5 divided by 2, that's 2.5. Now let's look at the ratios here. 10 to 4. Is that the same ratio as 15 to 6? Is that an equivalent ratio to 20 to 8? Well, 10 over 4 is equal to 20 over 8. What about 15 and 6? Well, if I divided 15 by 6, I get 2.5. If I divide 10 by 4, I get 2.5. 20 divided by 8, I get 2.5. Everywhere you look at this table, you are seeing constant ratios, equivalent ratios, okay? And to go from x to y, we're just multiplying by 2.5, 2.5, 2.5. So if I had 0 and I multiplied it by 2.5, I would get 0. So this table is proportional. It's got a constant ratio, and it would include 0, 0. Okay. All right, now let's look at this. To go from x to y, it looks like I'm just dividing by 3. 2 divided by 3, 3 divided by 3, 4 divided by 3, 5 divided by 3 is 5/3, 6 divided by 3. So if I had 0 and divided by 3, I'd get 0. Okay. So it looks like we have a constant ratio. You could also look here. 3 times 2 gets me to 6. Does 1 times 2 get me to 2? Yes, it does. 1 to 4. 1 times 4 gives me 4. 1/3 times 4 gets me to 4/3. Yes, it does. Okay, this has a constant ratio, and it would include 0, 0. All right, let's look at this guy down here. To go from x to y, well, it looks like I multiply by 2. If I multiply by 2, do I? No. If I multiply by 2, no. If I multiply by 2, no. Okay. Well, to go from 2 to 4, I would multiply by 2. Do I multiply by 2 and get, oh. To go from 2 to 6, I would need to multiply by 3. To go from 5 to here, I would multiply by 3. That doesn't look like it's going to work, guys. 2 times 3 gives me 6. Is 5 times 3 13? No. Okay. Nowhere am I looking do I see a constant ratio. And here's a ratio of 1/2. Are any of these 1/2? No. Okay. 0, 0 would not be in this table either. Okay, and what I will tell you, the rule for this table is double this number, add 1. 2x plus 1, right? Double that number, add 1, double that number, add 1, double that number, add 1. Okay, if I put 0 in here, my output would be 1. This is not proportional, does not have a constant ratio, and it would not go through the origin.